Hello everyone, I am Soumyodip Karmakar, a student of Bolpur College Chemistry Department, presenting my dissertation on application of colloidal chemistry. Before going to this, we need to know about three types of solutions. The first one is true solutions. What is true solutions? True solutions are those type of solution whose particle size is less than 1 nanometer, which is homogeneous, its appearance is clear, it cannot be separated by filtration, it doesn't settle, it doesn't show Tyndall effect, and it also doesn't show Brownian motion. Now the second one is colloidal solution. What is colloidal solution? Colloidal solutions are those types of solution whose particle size in between 1 nanometer to 1 micron. It's heterogeneous, its appearance is almost clear. It's not possible to separate it by ordinary filtration, but it can be separated by ultrafiltration. It doesn't generally settle down, but it can be separated by ultracentrifugation. It shows Tyndall effect and it also shows Brownian motion. Now, the third one is suspension. Suspension is nothing but a kind of colloidal solution, but it's different according to its particle size. Its particle size is greater than 1 micron. Rest of the properties are almost similar to colloidal solutions, but the main difference is its appearance. The appearance of suspension is turbid. Now, the classifications of true solution. True solutions are generally 9 types. When the solvent is gas, the solutes are gas, liquid, and solid. When the solvent is liquid, the solute is gas, liquid, and solid. And when the solvent is solid, its solute is gas, liquid, and solid. Examples are given. Now, the classifications of colloidal solutions or suspensions. It's generally 8 types. When liquid dispersed in gas, it forms liquid aerosol. Examples are fog, mist, etc. When solid dispersed in gas, it forms solid aerosol. Examples are smoke, dust particles in air, etc. When solid dispersed in gas, it forms solid aerosol. Examples are smoke, dust particles in air, etc. When gas dispersed in liquid, it forms foam. Examples are forth, leather, etc. When liquid dispersed in liquid, it forms emulsion. Examples are milk, oil, water mixture, etc. When solid dispersed in liquid, it forms sol. The examples are mud water, charcoal in water, etc. Now when gas dispersed in solid, it forms solid foam. Examples are ice cream, cake, biscuit, etc. When liquid dispersed in solid, it forms gel like curd, jam, jelly, etc. And finally, when solid dispersed in solid, it forms solid sol. The examples are ceramic substances, china clay, rock, etc. Now, the properties of sol. There are mainly 3 types of properties. The first one is optical property, the second one is kinetic or mechanical property, and the third one and most important property in this topic is electrical property. Now, Tyndall effect is an example of optical property, Brownian motion is an example of kinetic or mechanical property, and peptidation and flocculation are the examples of electrical property. Now, what is peptidation? In this method, converting a precipitate into a colloidal sol by shaking it with a small amount of electrolyte, the electrolyte used is called as peptizing agent, and the phenomenon is known as peptidation. Now, what is flocculation? Traces of electrolytes are essential for the stability of a sol, while the addition of a comparatively large amount of electrolytes decreases the zeta potential of the sol particles in order to make the sol unstable. As a result, the colloidal particles grow in size and are precipitated out. This phenomenon is known as flocculation or coagulation. Now the most important question in this topic is how the electric charge on the colloidal particles imparts stability to the sol. The colloidal particles carry a similar and equal charge, while the dispersion medium carries the equally opposite charges. Due to the presence of similar and equal charges, the colloidal particles repel one another and are thus unable to combine together to form larger particles. This keeps them dispersed in the medium and the sol remains stable. This is why sol particles do not settle down even on standing for a long time. Now, the types of electric charge on colloidal sol. It's generally two types, positive charged sols and negative charged sols. Examples of positive charged sols are metallic hydroxide such as ferric hydroxide, aluminum hydroxide, etc. And examples of negative charged sols are metal sols such as gold sol, platinum sol, starch sols, etc. Now from here our topic starts. The applications. First example is the tanning of leather. Using tanner we convert animal skin to leather. Animal skin, which is made up of protein, lipid, water, etc., is actually a colloidal solution. By using specific tanner, we actually input some extra electrolyte into it. Therefore, the extra electrolyte that is present in the sol is precipitated out and the aqueous layer evaporates, and the remaining part is called leather. The whole process is called tanning of leather. The second example is purification of water by alarm. Using alarm, we converted the contaminated water to fresh water. Water purification by alarm is a very useful technique that we use in our daily life. By adding some amount of alum in the contaminated water, the electrolytes react with the iron and mud particles that is present in the impure water, forced to precipitate it out. Therefore, the water becomes clean and pure. The third example is coagulation of blood. Here, fibrin acts as the coagulating agent. Coagulation of blood is another example of flocculation. If by accident any part of our body is cut and bleeding occurs, then some coagulant, that is fibrin, which is present in our body, comes out and transfused the blood. Therefore, bleeding is temporarily stopped at the wound site. Now the fourth example is artificial rain. It's a very popular example and it was a breakthrough discovery. Artificial rain is a breakthrough discovery in the perspective of science and technology, as well as another beautiful example of coagulation. In this method, some amount of electrolyte is added, mainly silica powder, into the air. Charged aerosol particles float in the air. By adding some electrolyte, the particles become discharged and its zeta potential decreases. Hence, the water particles bind together and becomes heavier and it falls to the ground in the form of rain. Purification of blood by electrodialysis is also an application of colloidal chemistry. Electrodialysis is widely applied in medical science. It is mainly used to purify the blood of patients with kidney failure. In this method, electrodes are placed with a continuous flow of distilled water that makes the process even faster. During this process, the contaminated blood is taken out of the body and sent back to the body after purification, although this process is painful. Formation of delta. Formation of delta is a natural example of coagulation. River water is a colloidal solution of clay. When river water meets seawater, the negatively charged clay particles gets coagulated by the positively charged ions present in sea or vice versa. As a result, colloidal solution of clay deposits and increases in height gradually. Continuous deposition due to coagulation results in delta formation. Now, formation of micelles and reverse micelles in soap detergent. Before going to this, we need to know what is micelles. Substances whose molecules aggregate spontaneously in a given solvent to form particles of colloidal dimensions are called association colloids. Association colloids of soap or detergent molecules are referred to as micelles. Formation of micelles and reverse micelles. Micelles have a polar head which is hydrophilic and a non-polar tail which is hydrophobic. When they are dissolved in water and their concentration is gradually increased, then after crossing a certain concentration, the non-polar tails aggregate to form spherical colloidal particles. They are micelles. Micelles are generally two types, normal micelle and reverse micelle. Normal micelle traps the dirt oil particles with its nonpolar tail into the inner sphere, and the outer polar part attracts the aqueous particles, whereas reverse micelle traps the aqueous particles with its polar head into the inner sphere, and the outer nonpolar part attracts the oil particles. Now finally, the conclusion arises. Therefore, colloids have wide applicability in our daily life and nature. Moreover, day to day, examples like milk, which is an example of emulsion, which is considered to be the best example of colloid. The shampoo that we get to use, printing ink, paints that we use for wall painting is also an emulsion. Liquid hand wash we use and the liquid metal polisher we usually use at home are colloids. Everywhere there is the footprint of colloids. This is my acknowledgement. Thank you so much.